But what about if you have, what if you have a square that, that looked like, this? Because this that's technically a square.
Because we're connecting points on the grid.
Connecting points.
But we have to find out how large that is.
Interesting.
We could just call it x since we're not really worried about that.
I think it's the square root of 2 apart. Because you have this triangle of dots, an isosceles right triangle. So these dots are the square root of 2 apart.
Interesting. Okay. So there are some sneaky squares hiding in there.
Yeah.
In here. Are there other ones like that?
Well, if you expand...
So you called this the square root of 2 case, which isn't quite consistent with how you label over here, but that's fine.
What if you what if you expanded out? We could have those as...
if we have the center and the center of the square, I'm just going to move this. Now we can expand this one outward, and we will get this square,
which is, it looks like it's a 2 square root of 2.
2 root 2.
Alright, so there's a 2 root 2. Are there any other tilty squares?
Well, you can expand this one further.
What if you had a sneaky one like...
And
if we expanded this one up, this one across. What if you had one like this?
Ooh, is that a square?
well, I think so, because if you draw a square,
If it's kind
I think I've done a few problems with this square.
Alright.
because you can make
We have
triangles.
I drew it wrong.
That's alright. Does that look like that's a square?
Yeah, because I've done problems where you have this square inscribed in a bigger square.
Alright, so,
So I think it is a square, but we
okay.
don't really know how big it is.
What could we call it? But I don't...
Well, if this is 1, if 3, 1, 3, root 10.
We kind of form a right triangle.
Alright, so that's a root 10.
1, 3, root 10 triangle.
Okay, can you find any
And-
other squares?
Well, there's another root 10.
But
Yeah, well that's the same size, so we're just trying to write down our cases here. You've got 0, 1, 2, 3, root 2, 2, root 2, you've got a root 10. Can you find anything else?
But we can't make a 2 root 10. That's too...
well,
Yeah.
no, because we've tried when we slide all the vertices here in relation to this one, you get a root 2, the 2 root 2 case.
Well, what if we...
And if we slid them to here, we just get a mirror image of this case. And if we slid them to here or here, we just get one of these. We just get this case.
What are you doing?
I'm just trying to
Yeah,
see.
this looks interesting.
There might be a smaller root 10 case in here. Let's see. This is a smaller root 10 case.
Well, you have, let's see, it's 1 up and 2 over.
And then we have all the we have those
Yeah.
triangles.
So what does that make?
Looks like it's a root 10 over 2 triangle.
It's a 1, 2, root 5 triangle.
Root
Root
5. Very interesting. So, let me give you a high five. That's a great find. That's a great find.
Can we
So
scoop them in?
You found 8 cases here.
Hmm.
8 cases. Okay, now that took a little while. It took about 8 minutes to find the 8 cases, but that's all right.
Yep.
All right, let's count them up now, okay?
Okay.
Yep.